This video will provide a step-by-step tutorial for building this sheet metal toolbox within Onshape. We'll cover everything from getting started in Onshape to building your first sketch, all the way through to exporting a flat pattern to be cut for production. Let's jump right in. The very first part of accessing Onshape is launching a web browser. I personally prefer Google Chrome, but you can use Safari, Firefox, really whatever you want, which means you can run Onshape from any device. So first of all, I'm going to go ahead and launch my web browser here. I'm going to jump over to cad.onshape.com. This is always going to be the best way to go ahead and access Onshape, bookmark it, provide a shortcut. From there, simply enter an email and password, and we're good to go. We'll start our design by clicking on Create and then creating a brand new document. We'll talk a little bit about documents as we go, but this is essentially your workspace as you're creating your sheet metal toolbox. Go ahead and name it something appropriate and hit Create. We're going to be presented with what should feel like a familiar environment for folks experienced with CAD. If you're not experienced with CAD, that's fine too. But we have our 3 planes and an origin, and we're going to start our design with a 2D sketch. A few different ways to start a sketch, either by go ahead and hit the sketch button in the top left. We can use our shortcut toolbar that's accessed through the S key. We can use keyboard shortcuts like Shift S. No matter what, we're going to go ahead and create a sketch. We're going to select the front plane, and then we can use the view cube or the N key to go ahead and view normal to this plane. And then we can use the P key to hide the planes and give a clean working environment. We're going to go ahead and provide half of the profile for our toolbox because we're going to take advantage of symmetry and minimize the amount of work we actually have to do. So we're going to start by sketching some lines. So go ahead and access the line command. Let me go ahead and browser zoom a little bit just to make sure that we can see everything as we're working. But we can go ahead and use the line command. And then if we click once on the origin, we're going to be able to drag to select the secondary point. So as we go, if I go ahead and click again, we'll be prompted to enter the dimension. We're working in inches here of this first line. So I'm just going to key in using my keyboard 2.5. And then you'll see I'm still in the line command. So I can keep going. I'm going to snap to vertical here on the second one after I snap to horizontal on the first one. Key in 1.5. We'll then create a diagonal line up and to the right. This one can leave undefined for now, and then we're going to have a horizontal one that actually snaps to just above the origin. Finally, we'll go ahead and drop this down right back to the origin to create this closed profile, and we'll key in one more dimension here. We'll key in 3.5 inches. So we'll see we have a mostly defined sketch, and if I hit Escape, I can actually exit the line command. I could have clicked it again as well. But we'll see we have mostly black lines, meaning those are fully defined, with a little bit of blue. The blue means we have an underdefined sketch. We'll see if we actually click on this vertex and drag, this is where the freedom remains. So we're going to go ahead and use our dimension command, or we can use the D key. Click on this vertex here on the top, as well as the vertex on the left. And then we can go ahead and drop this in. We're actually going to have this be a bit of a formula. So we'll key in 15/8. It's going to be 15/8 of an inch. And we'll see that when we drop that one in, this dimension looks a bit different than the others. Right? This one has this F, meaning it's a function. If we hover over, we can actually see what the expression is that defines this dimension. So now we have a fully defined sketch. Great. So if we hit the check mark, we have now created our first feature. We'll see our sketch shows up in our feature tree, and we can go ahead and start to create some 3D geometry. So we are going to be working in sheet metal, but you'll find that in Onshape, sometimes the best way to create your sheet metal geometry is by creating a solid part first as the tool to then create the sheet metal. So I'm going to go ahead and use the extrude command. Again, you can use the S key and customize your shortcut toolbar, or utilizing keyboard shortcuts, this will be Shift E. But I'll go ahead and click the actual icon, click on our face, and now we're going to go ahead and key in a depth of 6 inches. we will again take advantage of symmetry. So we're actually only going to define about half the depth. The total depth of this toolbox is going to be 1 foot, 12 inches, but we'll start with 6 inches and take advantage of symmetry later. So we'll see we now have our second feature. We've extruded this out. We have one part. And now we're actually going to make some sheet metal. So we're going to go ahead and use the sheet metal command here on the far right of our toolbar. And we're going to use the convert option. This is where when we start with solid geometry, we're then going to convert it over to sheet metal. So if I click on my part, I'll see that every face becomes a separate sheet metal face. In fact, they all become separate parts. We'll touch a little bit on multi-part in just a second, but let's focus on completing this sheet metal command. Now, we talked about taking advantage of symmetry, so we're actually going to exclude a couple of faces, meaning we don't need them right now. So if I click on this sort of back face as well as the end of my extrude and these two top faces, we now have what is a simpler sheet metal component. And then what I can do is choose where to create my bends. So I will choose these two bottom connecting edges to create my sheet metal bends. And now I can see I actually just have one part because I've excluded some faces and I've connected the remaining faces with these bends along edges. But now we need to go ahead and continue to define the parameters of our sheet metal. So a few different important things here is the thickness. So thickness and bend radius in sheet metal are often determined by the type of sheet metal you're working with. And there's some predefined best practices, standards around this. So what we're going to do is, because we're actually going to use a few different sheet metal models here, we're going to define our thickness using a variable. So when I go over the thickness input, if I use the pound symbol, Onshape will prompt me to create a new variable on the fly. I can go ahead and name this. So what I'm going to do is name it T_22, meaning the thickness of 22 gauge sheet metal. So this is another expression here, and we're going to key in 1/32, and then we'll specify a unit. So we'll say 1/32 inches. That is the thickness of 22 gauge sheet metal. And you can see as soon as I confirm that, we have a new variable feature in our tree just above our sheet metal model that allows us to go ahead and use that on the fly. Similarly, we'll create a bend_22 new variable. This is 0.075 inches. And now we have these variables that we can reuse later or change along the way and make sure it affects all of the sheet metal within this part studio. Great. So now there's a few other inputs. We're not going to mess with any of these for this particular design, but Onshape does give you control over K-factor to understand the exact precision of the bend geometry. A couple different ways you can define this with bend allowance and deduction. You can also define your reliefs. These can be corner by corner, but you can also define it on the entire model. In this case, we're going to use a closed corner, but there's a few different options that we can use. And all of this, of course, rolls through to the flat pattern that we'll get to in just a second. So that is the definition of our first sheet metal models. If you go ahead and confirm this, we now have a great starting point to continue to work off of. So this is kind of setting up the overall geometry. And now we want to add just a few different details to this. So what I'm going to do is actually add a hem. So if we hit the drop down of the sheet metal tools, or if we use the search tools, this is a great function to go ahead and find the exact tools that you're looking for. It'll highlight it in the toolbar. We'll give you a quick tool tip. And here we're going to go ahead and select this edge of the side here. So we can go ahead and define this as 1/2 inch, and we'll see our hem get created. We have control over things like rolled hems, teardrop style, but in this case, let's use a straight hem, and we can go ahead and confirm that. Now, the $1 million question I'm sure everybody is asking. What about my flat pattern? In Onshape, there's no flatten and unflatten steps or operations. We are going to be able to do everything in the bent and flattened state simultaneously. The key here is this sheet metal table and flat view flyout on the right-hand side. When we go ahead and click this, we have full insight into the flat pattern while viewing and working on our 3D model. We can go ahead and hover and see the cross highlighting that occurs. We can even sketch on this right-hand side to create parameters that maybe we even cut through a bend. We're going to see all of this in real time. We don't have to flatten and unflatten. We're going to get real-time feedback as to whether or not what we're making in the 3D or flattened space has conflicts in the other one, has manufacturability. All these guardrails and this visibility is going to be available as we're actually designing. Let me go ahead and cancel that. I'm actually going to get rid of my sketch too, just a proof of concept. Now, the next step is to go ahead and create one more sheet metal component. So what we're going to do is we're going to create another sketch, and we're going to create the handle of our toolbox. So again, sketch, Shift S, we can use our shortcut toolbar, it doesn't matter. But one thing here is instead of picking a plane or a face, which of course we could, we're going to go ahead and use Select Mate Connector as the way to build this sketch. So once I select that, when I hover over the geometry, Onshape Mate Connectors show up at relevant geometric locations. There's a lot to Mate Connectors. I highly recommend doing some reading on what we've done here, but this is a Swiss Army knife of a tool in the CAD space. So Mate Connectors are going to be what really drives all of our logic in the assembly and mating space, as the name sort of alludes to, but is a powerful tool in the design environment too, because it provides essentially a mini coordinate system that we have control over. In this case, we're going to use what we call an implicit mate connector, meaning we're using the existing geometry to imply locations to use this. But this is just a great tool to go ahead and use instead of sketching on this face. I'm going to use my shortcut toolbar using S, and I'm going to go ahead and define just the profile of our handle. So what I can do is go ahead and start on this edge, and then I'm going to snap it horizontal and then vertical to that other vertex. Then go ahead and draw one more line up. I'll key in 1/2 inch. And then it's still blue, right? So I'll escape out of this. I'll use the D key to turn on the dimension command. And I'm going to dimension between these two vertices. We're going to do 1/10 of an inch here, and then our sketch becomes fully defined. Now, we're going to make an additional sheet metal model. But instead, this time of using convert, we're going to use extrude. So there's a few different ways to do this. Convert, we obviously started with a 3D entity. Extrude, we're going to take a 2D profile like I've just created and extrude it out as sheet metal. Thicken is a great option to be able to sketch a 2D profile and then thicken it into sheet metal as a starting point. That may be more familiar for folks who have designed sheet metal in other systems. We provide flexibility, really kind of whatever suits the needs in that moment. In this case, extrude in this profile made the most sense. We have, of course, parametric controls here. So instead of going blind and defining it, I want to make my model as parametric as possible. So I'm going to go up to face. I'm going to select the end of my existing sheet metal component so that we make sure that this extends up. We will use those variables that we defined earlier to define our thickness and to define our bend. We can access them just by pressing the pound key and then selecting the appropriate variable. And then I can go ahead and confirm that sheet metal model. Now, what have we just done? We just built a whole sheet metal part in the context of our other sheet metal components where we needed geometric relationships to define them, right? We defined this profile based on the existing profile of this end of the toolbox, and we defined the length based on the existing length of our toolbox as well. Right, we've just built in robust parametric controls to allow us to adjust parameters and know that both of these parts are going to update in accordance. Onshape multi-part modeling is very simple and very powerful. These are not bodies, right? I can see I have in my parts list 2 different parts. Let's go ahead and add a name so that we don't lose track of this. So I can right click on this and go to properties. And I'm going to say this one is our base. And then one of my favorite shortcuts is I can select part 2, Shift N, and in line I can go ahead and edit this name. This is the handle. Now, it's important to also name our features along the way. So I haven't been doing the best job of that, but I think a few crucial ones too are the actual sheet metal features here. So I can use that same Shift N and say this is SM base. Spacebar deselects. This is a great thing to know in Onshape when we have the persistent selection. You may notice as you go. So spacebar is going to clear that. Shift N again, SM handle, and now it's a bit clear. And it's really important, particularly on sheet metal, to name these because as we go back to our flat pattern view, we actually have multiple flat patterns within this same part studio. Right, I have my sheet metal base, and you can see that up here, but then I can switch and see my sheet metal handle. We're going to manage both flat patterns in this same part studio, just like we're managing both parts. And of course, everything's going to update in real time and be parametric together. Now, let's add a few more details to this handle. So we're going to add one more hem along this top line. And now we have, by default, it goes along the outside. We actually want that along the inside of the model. So I'm going to go ahead and flip it in the opposite direction. And then we see in real time that we have a collision. Onshape is going to alert us to this. If we were doing this in the flat, we may not see that. But we're going to go ahead and change this then to 3/8 of an inch and remove that collision. The other thing we're going to do to the handle is add a flange. So in the same sheet metal drop down with all of our sheet metal tools, we're going to add a flange. So we'll select the underside here, and Onshape is going to go ahead and create that geometry. We're going to make this 3/4 of an inch. And if we zoom in though, we see another issue, right? We see these are actually overlapping with the other sheet metal geometry. So what I'm going to do is actually define the flange alignment. So what this does is control exactly where this bend occurs and where the flange ends up based on the existing geometry. So inner, we have that full overlap. If I go to outer, we find that they line up kind of in the way that we wanted, in the way that we expected. Middle, of course, goes right in between. In this case, we want outer for this flange. Great. Now, we are at a point where we can take advantage of symmetry and really round out our sort of preliminary design of this toolbox. So what I'm going to do is use the mirror command. This might be something that you put on your handy toolbar. I don't have it on mine right now. Search tools as well. If you can't find the mirror command, just search for it. It'll highlight in the toolbar, or you can select it right from here. In this case, we actually select both parts to mirror. And it doesn't really matter which plane we mirror over first. I'll use this one. I'll use the right plane essentially. An important thing to know here, every Onshape feature, because we are in a multi-part environment, you have the option to create new parts or add to existing parts. Right now, we're actually creating 2 additional parts, which isn't what we want to do, right? We want to add. But there's also other tools embedded, right? A mirror cut, for example, a remove is embedded right within this tool. An intersect as well, if we want to perform that. So everything from extrudes to revolves to lofts, right? All of these add, remove, intersect, new, all of these commands are always at your fingertips. So don't go looking for an extrude cut, for a boss cut, right? That's all embedded within a single tool. Another place that we're going to see mate connectors show up is right here, right? Instead of selecting a plane, we could use a mate connector. These are everywhere. I'd highly recommend checking those out. We'll go ahead and confirm that. Go ahead and make one more mirror. Go ahead and select both parts again. We'll select this front plane now, do an add, and now we have taken advantage of symmetry and very quickly created what looks like a great toolbox. Flat patterns are going to be fully updated as well. Now, good job on the modeling. But you may have noticed along the way, or if you're familiar with other CAD systems, you may be looking for the save button, right? That was actually a good amount of work to do without ever saving. Maybe that wasn't great practice. Well, in Onshape, yes, it was, right? There is no save button anywhere within Onshape. All of the work we've done is completely tracked, recorded, and preserved for us. So the key to all of this is a very, very important flyout called the versions and history graph here in the top left. When I select the versions and history, I can expand the changes and see every change I've made to my design since the very first thing I did. Right? I can see I started my model and then I inserted sketch 1. Everything along the way is captured. When I added that sketch in the flat pattern and then deleted it, those are line items within here. All of this is totally accessible, retrievable, and happening automatically. For example, let's go ahead and go back. Right? If I want to come back a few features ago, maybe right before these two mirrors, I can go ahead and view that previous point in time. Right? I can go ahead and compare to the way my design looks currently. So I did that quickly, but that was a right-click compare. And here I can see what features have been added or removed or changed between one time and another. I can visually drag between one point in time and the other to see where the changes are. And what I can do is actually jump back to any previous point in time. Or if I want to jump back and restore prior to those mirrors that I added, I can go ahead and right-click, restore, and be able to actually jump back in time to that previous point. That restore is simply a line item in here. I didn't overwrite any changes when I did that. So what I also have the ability to do is come back and restore before that and essentially undo my undo. So just to pause for a moment and think about what that means. You will never lose data due to a crash. You will never lose data due to a mistake. You can never get to a point so broken that you can't go back to a time that worked. All of this is captured automatically, fully retrievable. Now, what I'm going to do is actually make a version, though, that creates a pivotal point in time that will stand out among the other changes. Right? Every single change there may be hard to find any particular point in time, but I'm going to say initial design has been completed, and I'm going to mark that with a version that stands out, uneditable, undeletable, will always be easy to access as a prior point. From there, I actually want to make a few investigative changes. So what I have the ability to do is try things out in a completely separate workspace by creating what's called a branch. So instead of save as, instead of a pack and go, I have the ability to right-click branch, and in here, I want to try some things out related to forms. I'm going to say forms testing up in this branch. And what you'll find is the work done in this branch is completely isolated. So if I go ahead and go to the base and I edit the appearance and I make this maybe more of a rustic color, I go to the handle and I do something similar. Whoops. This is not reflected back over in the main workspace, right? So we have a space to test, a space to try things without affecting maybe what other people are looking at in the main space. But let's keep working, all right? Let's keep designing. So we actually want to do something before the mirrors. So like any good parametric CAD system, I have the ability to roll back right before I mirrored. And we're going to do two things in this branch. We're going to create some form features and we're going to drill some holes. So we're going to make one more sketch, and this time we'll just do it on this bottom face. N key brings me normal, and I'll zoom in a little bit. And we're going to create some construction geometry to create a location for our forms. So I'm going to use a corner rectangle command, and I'm going to put it into construction mode. So this can be the shortcut key Q, or just click this button, start at the corner. We can drag out. Then I'm going to apply a couple constraints. I'm going to apply an equal constraint where I can either use the shortcut E or use this and make this a square. And then I'm going to apply one dimension to it. So I'm going to go ahead and say this is a 1/2 inch. Because it was equal, that's going to apply to both sides. And now this becomes fully defined. Now, we're essentially trying to add some vibration reducing form features to the base of our sheet metal. So if I come into the sheet metal dropdown, I can find the form command. I'm going to go ahead and select this vertex. And then I'm going to find the circle emboss within the built-in form feature library. This Onshape has a wide variety of built-in forms, but also allows you to customize your own form library with plenty of documentation and training on how to do that. So in this case, we want to find the circle emboss, and we want to use diameter of 5 millimeters, height of 2 millimeters, and an angle of 90 degrees. Go ahead and hit done, and now we have our form feature. Go ahead and hit confirm, and we'll find that that, of course, mirrors across once we're done. We have one more thing to do. I want to go ahead and sketch one more time. We're going to make a location to drill a hole to mount our handle. So if I go ahead and select this face as my sketch plane, I can again use some construction geometry, this time a line, but I'm going to hit Q to make it construction. You can see that turned on. Find the midpoint here, should auto snap to it. And then we'll find our midpoint on the right and drag over until we're vertical and horizontal. Find that center point right there. From there, we'll use our hole command. And we'll select this one point. And in this multi-part environment, we're going to find this hole actually goes through both parts. We can create features that affect multiple parts in one. So we can see our merge scope here is base and handle. If we don't want to affect the base, we can simply remove it from the merge scope and simply just drill through the handle. But we do want it through both. We want to create a mounting hole here. So we're going to go through both. We'll use a drilled hole, 9/64ths, and we can go ahead and confirm that. Awesome. Now, let's go back and we can right-click roll to end. And we'll see that our form features, as well as our holes, have mirrored appropriately, and we got a pretty good looking toolbox coming together. Now, remember, we're in a branch. We're actually testing things out here. So I'll again use this compare, and we can actually do this across branches. So if I'm on one and I right-click on the other, I can go ahead and compare again. In this case, it might be a bit more interesting than that last one, which was pretty obvious. But in this case, I can see the features, the components that have changed. You can see the visual highlighting that occurs. And I can go ahead and drag from one to the other as well to be able to understand that difference. Now, if we go back into main, I actually want to make some changes over here. This can be happening in parallel, and that's the beauty of this whole environment. You can try things out. You can have multiple teammates working together, trying out some parallel ideation. But what I want to do over here in this main branch is very, very quickly and easily configure my toolbox. Now, this is a type of product that may well come in multiple sizes with some shared underlying design themes, right? It may look similar, but we're just going to modify some sizing. So we can do this in about 60 seconds here. We can open the configuration panel and we'll choose to configure our part studio. Now this can be very straightforward, right? We'll type in here maybe small and large, and then we'll choose what features, what parameters get configured with this. So what I'm going to do is go ahead and click into sketch 1, and we're going to control the height. All right, we'll add that 3.5. And then we're also going to control the depth of this first extrude. And what we can do is say the one we designed first was our small size. Now we're going to make our large size. Maybe that's 5 inches tall and a total of 16 inches long. Now let's take a look up here on the top left. We can access all of our configurations. Let's look at our large one. That maybe looks a bit weird. Right? Maybe we didn't just need to control that total height parameter, but we actually need to access other parts of that sketch to make sure maybe these walls are too low for that height. So very, very simple. We go back, we configure features, access into sketch 1, and we'll select this 1.5. And then maybe, this one needs to be 3 for our tall one. Yeah, that looks a bit better. So just like that, we've configured our sheet metal. We have multiple sizes. There's a lot we can do here, right? You can have checkboxes, maybe with or without the forms. There's variable inputs. There's a lot we can do with configurations, and you can have separate individual configuration inputs. But now, getting toward the end, we have worked in multiple branches. We have created forms. We have done a lot. And in fact, we've done multiple things in these branches in parallel. Now, only Onshape has the ability to take this testing branch and actually merge and combine changes from multiple work streams. There are changes in main. Main's been edited. There are changes in the forms testing, been edited. I could choose to just replace or keep. Honestly, it's kind of what other systems do. They totally overwrite. Onshape allows you to take changes from both and merge this together. So we are now back in main and we have our configurations. But we also have these forms and these holes that is going to allow us to assemble these components properly, add a bit of vibration reduction. We have now worked in parallel work streams and combined that work. Final step here, there's other things we can do with drawings and assemblies. For the sake of this video, I want to go ahead and export the flat pattern for our base to show that, because that is the important product of this design work. The design doesn't necessarily matter. We want to help you manufacture physical things, which means we can go ahead and right click on our flat pattern, export our DXF, and we can choose our settings related to this. We can export both flat patterns or just one. We can download it or even email it to somebody directly from here. I want to store this in a new tab just to show what it looks like. A lot we can do here to control how form features come out, how bend center lines look. But let's go ahead and export this flat pattern. And then let's go ahead and view it right within Onshape. All right, we have another tab that was just created in our document. Onshape documents contain all types of different data. So let's go ahead and click in, and now we have our flat pattern for our base. We are ready to send this and get it cut. We can see our form features. We can control our layers. Right? We can hide and show things like cut lines, form lines, bend up, bend down, have control over all of that. Remember, we have been in a web browser this entire time. There are no downloads or installs for Onshape. We can share this document. We can send someone a link. In fact, I'll put the link to this document in the description of this video. Really appreciate everybody watching. Please let me know what you think of this type of content. I hope it's useful. go into Onshape, build some sheet metal, make things happen. Appreciate everybody. Have a great day.